My name is Dylan Ratcliffe. I'm the founder and CEO of Overmind. And today I'm going to be talking about, is Clippy useful yet? Do we finally have a thing that can actually help us do our jobs rather than just be really annoying and have a lot of hype? Before I go into this, I want to just do a quick survey around the room. Around who's been using LLMs up to this point. So put your hand up if you have used some sort of an LLM, ChatGPT, etc. Okay, almost everyone. Put your hand up if you've done that via an API. Put your hand up if you're doing it via an API in production. Okay, all right, a few people, cool. So almost everybody has dealt with an LLM before, quite possibly with ChatGPT, maybe with hitting one of the commercial APIs, maybe running it locally. But for those of you that aren't super familiar, a large language model is trained on a massive corpus of text. You put text into it, and it does magic, and text comes out. Now, the first question, and the topic of this meetup, is how are LLMs related to observability? And my first assumption was that they wouldn't really be related to observability because LLMs are based on text. They're very good at processing large amounts of text and generating it. Observability consists of metrics, which is a big pile of numbers, not text. And LLMs are particularly bad at numbers. Try getting ChatGPT to do maths. It's very bad. Traces, which are basically another big pile of numbers with a little bit more structure and a little bit of text, but not very much. And logs, which are actually big piles of text. So the obvious thing here might be, well, LLMs are good at dealing with text. We should be piping our logs into LLMs, and that's how they relate to observability. I'm going to disagree with that. One of the reasons is that it is currently, after OpenAI halved their prices, it is now only 5 times more expensive to send your logs to OpenAI than it is to print them out on paper, as of numbers that I found on the internet yesterday. It's still quite expensive to do this. It is very slow. It's fast in terms of somebody reading, but it's very slow in terms of ingesting logs. And I don't know if you're going to get that much value out of it. So I'm going to propose something different. Rather than using these typical things, what I want to propose is preventing outages using LLMs, which maybe isn't quite observability. You would use your observability tools if an outage happened to work out what went wrong. So maybe it's kind of close. I don't know if it is observability, but it's about as close as we can get. So what we're going to do is we're going to make a change to some imaginary infrastructure, which actually I do have real infrastructure that does this, so I know what this change does. And we're going to ask an LLM what might happen, what might go wrong if I make this change. And we're going to see how good it is. This change is we are using Terraform to manage an ECS task definition. So this is Amazon's container service. You write a task definition, you say which container you want it to run, and it runs it for you. We are changing the health check from port 80 to port 8080. Now, before we ask an LLM what might go wrong, I want to set a baseline, and I want to ask the room of smart people who've done observability what might go wrong. So what might go wrong if I apply this change to production?
So container port 80. Yeah.
Container port 80.
The container is running on port 80?
Yeah.
What's wrong with that?
Switching to 8080.
This should also be switched, do you mean?
Yeah.
No, the health check cannot be done because your application run on port 80 and the 8080 is not available.
Okay, yep. Anything else?
It might be available and you're not exposed.
It might be. Anything else that might go wrong? All right, we can stick with that. So the room full of smart humans has said that probably what might go wrong here is that we're changing the health check to 8080, but the container is still running on 80. So is it that the health check deliberately runs on a different port, or have you just made a mistake? Is that you've updated the wrong thing, or you've mistyped it or something like that? So that's the risk that a room full of smart humans have come up with. I want an LLM to do as good or better. I think that that's where we should set the bar. If it can't do better than me, or at least be less lazy than me, and just as good, I don't think it's that useful. So we're going to set the bar there. We want to outperform that assessment of what might go wrong. So one of the biggest things that influences how good an LLM is the model itself. They're trained on a big pile of training data, but they are both more than their training data and less than it at the same time. They're more than it in that they can come up with answers that they weren't trained on, which are correct, but also they can totally forget things that they were trained on. So just because something was trained on every Stack Overflow answer in existence doesn't mean it can regurgitate every Stack Overflow answer in existence. These are the models that I've tested this against for this presentation. So we've got Gemma 7b from Google, Llama 2 from Meta, Mistral from Mistral, Lava, which is Microsoft and a bunch of universities, and both of the GPT 3.5 and 4 models from OpenAI. All of them are open source except for the OpenAI ones, and you can run all of these locally on your laptop. Oh, well, I can on my laptop. It seemed to be fine, so probably it's not that hard to run. We are going to evaluate them based on these criteria. Firstly, is what it says dangerous? Is it going to make my life markedly worse if I listen to it? Secondly, is it at least correct? Is it at least saying something that isn't wrong? Just because it's not wrong doesn't mean it's good, but it should at least be not wrong. Is it convincing? If I'm asking what might go wrong when I make that change, and it says, well, I mean, something could go wrong because there could be a power outage and it could fail. That's not convincing. It's true, there could be a power outage, but it's not convincing and it doesn't help me. And the last thing is, did it catch the issue? I know what actually happens when you deploy this because I've done it. So I can also see whether it correctly predicted what might happen. So I ran the prompt through these LLMs. When I say ran the prompt, I mean I took that code and I appended the words what might go wrong and I stuffed it into the LLM and then it printed out some text afterwards. This one, Llama 2, was by far and away the worst. It discovered 6 potential issues. Every single one of them was wrong. It told me that I was missing the JSON encode function, which I wasn't. It had told me that the essential field wasn't required because it's already marked with essential, which it isn't. The interval for the health check is missing, which it's not. The retries field is redundant, which it isn't. I'm missing a timeout on my health check, which I'm not. And the command is wrong, and if you just replace it with this other command, it'll now work, and of course the other command is exactly the command that's already in there. And so these recommendations would have made my life worse if I implemented them. I would have removed the JSON, I would have added another JSON encode function, the essential field. It's very bad. They're wrong. The problem, though, was that they were convincing. It is very confident in these answers. It says the essential field is not needed in this case as the container is already marked with essential equals true. You can remove the essential field to simplify the configuration, which you can't. That won't work. But it was very confident in the way that it told me, and so it was actually pretty convincing, which is terrible. I would have rather it not be convincing because it's wrong. And it didn't catch the issue.
It's actually scarily convincing, that's the thing.
It is scarily convincing. This is a particularly bad example, though. So I went and did this on all of the others, and they were better. A middle of the range one was something like Mistral. That was actually quite impressive for an open source model. Mistral said, the container being used may not be listening on port 8080 by default. In that case, you will need to ensure the container is configured to listen on port 8080 and modify any other codes, such as inbound rules for security groups or load balancers accordingly. Which is not dangerous. It's pretty much correct. It's not very convincing. It's like, well, it might not be listening, and then you might need to update other things, which might exist maybe. It's not something where if it was in a list of 5 or 6 outages, I would stop the deployment because of it. On the high end, we have GPT 3.5 and GPT 4. 4 was better, but 3.5 was also a lot better than the open source models. GPT 4 tells us this. If your service within the visit counter container does not listen on 8080, the health check will fail. ECS Elastic Container Service relies on health checks to determine the status of a service. If the health check fails repeatedly beyond the configured retries, see, I do need retries, ECS will mark the task as unhealthy. This can lead to constant task restarts and potential service disruption as ECS attempts to heal the service by replacing unhealthy containers. GPT-4 is wordy, but it is a bit more convincing, I think, because it sort of showed off, it flexed its knowledge by telling me what would happen with ECS, and it sort of proves that it knows what I'm talking about. It wasn't a lucky guess. It actually does understand how ECS works. So I would say that this is reasonably convincing. The problem with this is that it will spit out 5 of these and they'll all be just as convincing, and they won't all be right. This one is right. That is the problem, but it'll spit out a bunch of them not necessarily right. So can we make this better? You will probably have seen examples of what is called prompt engineering, where you improve the output of a model by saying, I will tip you $200 if you do this. Or I have a disease where one of my fingers falls off every time you tell me something that's incorrect. They have sort of been shown to work, so I tried them. I said, you are an expert in AWS, Terraform, and incident management. You have deep understanding of outages, what causes them, and how they can be prevented. Your job is to answer a question provided below. If you answer the question correctly, you get a tip of $200. And this is what changed. Llama actually got a fair bit better. It was still awful, but it went from being extremely dangerous to being not terribly dangerous. And it became less convincing, which is good. But the others didn't really change very much. We can see that GPT 3.5 and 4 both improved slightly. Lava got a little worse. But something that you need to be aware of when you're doing this is that the responses are not deterministic. They're somewhat random. They come back differently each time. And so it is very easy to fall into confirmation bias. You look at part of the response and you say, oh, that was better. Therefore, what I did was an improvement. Not necessarily. That could have happened purely by chance. You need to run it a bunch of times and with a bunch of different scenarios to work out whether it's actually an improvement or whether you just got lucky and it's going to switch back to being dangerous the next time you run it. Llama, in this instance, I ran it a few times. It was actually an improvement. These ones I couldn't be bothered running a bunch of times because it wasn't obvious. It wasn't massively better anyway. So I'm not saying that prompt engineering isn't valuable. You have to do it. What you ask the LLM to do is the most important thing because that's all you do. You just put text into it. But simple stuff like threatening it or bribing it or whatever doesn't really help. You need to think about what you're asking it to do, what you're asking it to produce in order to get serious improvements. The other thing we can do is something called retrieval augmented generation, which, like all stuff with AI, is more complicated than it actually is. Basically, you stuff some documentation into the prompt as well, and then it uses that to potentially return a more intelligent answer. I did this. So I looked up the documentation for ECS tasks in both Terraform and AWS, and I copy-pasted it into the prompt, and I ran it all again. Now, what happened was that they all fell over and didn't work. The reason is because LLMs have a context window, which is the limit of how much stuff they can take in and spit out combined. And if you go over that, they won't work. Or, like Gemini, they'll start spitting out the word terror, 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 terror repeatedly forever. I broke its brain. So you had to sort of cut back the documentation. I just did this manually. I just picked what I thought was relevant, pasted it in. Obviously, that doesn't scale, but for the sake of this, that's what I did. The results I got were not much better, to be honest. I think the reason is because the question we're asking, what might go wrong, is not likely to be improved by knowing the documentation. In fact, GPT-4 has already proved it doesn't need the documentation. It knows a hell of a lot about ECS as is. Having the docs is not really going to get me a better response than this. Like, what would I actually expect from the documentation that would improve this? Not much. So basic stuff like the docs is not necessarily going to help unless you are asking a question about the documentation. You need to provide stuff that is relevant to the question that you are asking. I don't have an example of this, but I have done it before and can speak from experience that if you provide information from your company that the LLM was not trained on, and you ask it questions about your company, you will get really good results. If you put all of your, procedures in there and ask it about your procedures, or an outage report and ask what the root cause was or something, it will do a good job. Now, that, however, doesn't work automatically because I did all that manually, right? So if you were going to build something like this to actually help you not have outages, you would need to automate it. The way you automate this retrieval augmented generation is using a vector database. A vector database is like a regular database, but it doesn't have a query language. It's not SQL, it's not anything. You just put a sentence in there and it responds with a result in sort of natural language. The way that it works is it takes the text and converts it into a list of numbers, which is called a vector embedding. And so to visualize this, I've created a really simple vector embedding model, which has two vectors. One of them is the number of bedrooms, and the other one is how haunted it is. And we're going to create a real estate database based on these vectors. So we're going to insert all of our real estate listings, and we're going to rate them on how many bedrooms and how haunted they are, or how likely they are to be haunted. And we're going to put them in a graph. And then we're going to query our real estate database for Dracula, which is obviously a pretty inappropriate query for a real estate database, but you can sort of guess how many bedrooms Dracula might have and how haunted he is, and plot him on the graph, and then return everything that is close by. And that's literally how these things work. And you can tell that the results you get are pretty on brand for Dracula, despite the fact that that is a ridiculous query to make of a real estate database. They seriously work like this. It's weird, but I mean, it's more complicated than that, but as you can imagine, but this is essentially how they work. It's why you can put in anything at all. You will need to tune stuff though. It's not quite this simple. Do you want to know, for example, the most relevant sentence to Dracula, or the most relevant paragraph, or the most relevant entire Confluence page? Remember that you have a limited context window to deal with, so if you get the 5 most relevant Confluence pages, you're probably going to blow through that window really quickly. By the same time, token, if you get the 5 most relevant sentences, it's not going to make any sense because the sentences don't have any context around them. So you will need to tune that. It's not so easy that you just plug it in and turn it on, but it's not terribly, terribly hard. It's not that much more complex than a SQL database. All right, so I've been going for a little while here, and I want to talk about how far we can take it. So if we use all of the things that we've spoken about so far, we select a model that is already quite good. We use prompt engineering to improve the prompts. We use resource augmented generation to give it relevant stuff. Can we actually answer this better than the room did? I would argue that the GPT-4 one is already not terrible, but it's not that convincing either. And if it was in a list of 5, would you, or all this convincing, would you really know? It does need a bit more. I'd say this is maybe as good as the room, though. So we've done this at Overmind. I learned all of this because we built a system that does this. And it combines all the stuff we've learned so far and means that both you and the LLM have access to, when you make a change in Terraform, you have access to the change you're making, the resource in AWS that it corresponds to, everything that depends on that resource, everything that depends on the things that depend on that resource, et cetera, et cetera. Not your whole AWS, we know when to stop, but you get a whole dependency graph of everything that may be affected, and all of that goes into the LLM as well. And then it's able to take that quite large amount of information and distill it down into a set of what might go wrong. And the result that we get is this. The container's original health check is configured for port 80. The task definition has mapping suggesting the application is indeed listening on 80. Changing the health check to 8080 without verifying the application has been reconfigured to listen on this port creates the risk that the health check will fail repeatedly, leading to ECS continuously restarting the service. It's not bad. That's basically what we got initially, but it goes on. It says the current target group, EC9B, whatever, associated with the ECS task is expecting targets to be healthy on port 80, meaning that the update to port 8080 for health checks doesn't align with the present expectations of the load balancer's target group. Since the health check is crucial for the load balancer to determine if the task is healthy and can receive traffic, misconfiguration here can lead to service outages. And I think that this is the piece of information that takes it from a believable thing that maybe you would listen to something you would definitely listen to, because it has correlated an extra piece of information that we didn't give it, and it has been able to say, not only does it look like it's probably wrong in isolation, but actually looking at the load balancer, which you didn't tell me about, it's also pointing at port 80, this is almost certainly wrong. Or maybe you need to go, there is another risk down here that says you need to go and update the load balancer as well, because that might also be the solution. Might be that you did the correct thing, but you need to update both at the same time. But you can get, I would argue that this is better than we came up with as a group of humans. In fairness, the group of humans didn't have access to the massive graph of AWS, but also...
It's on the end of my tongue.
But also it would have taken us ages to go through that and find it all anyway, and we wouldn't have been bothered to do it because we got work to do. So, to summarize, this stuff is reasonably straightforward. These three things of picking an LLM, doing some prompt engineering, integrating with a vector database can get you really quite good results. I think personally that applying it to changes you're about to make is quite a good thing to apply it to, because it's not a huge data set. It's something that's important, but you can apply it to lots of other stuff. I implore you to go and try this stuff out. Almost everything I used here was open source. You can run it on your laptop. It's not terribly difficult. The mapping AWS is quite difficult. I've spent like 2 years doing that, but the sending stuff to an LLM is quite easy. Thank you.